Hi. Today I'm going to just give a brief. I just read this book, uh, Brief History of Humankind, *Sapiens* by Yuval Noah Harari. So I'll just try and explain some things about, at least the first chapter about it. Just read it a couple of days back, and so I give the first chapter. First chapter deals with something called as evolution. I mean, human evolution. So he tells us about humans first evolved somewhere in Africa around 2.5 million years ago. And then around 2 million years ago, these went out to different countries like Europe, Asia, and stuff like that. So basically, uh, I mean, the thing is that you say in Europe and Asia are different kinds of environment, right? Europe is very cold. Asia is hot and humid, right? Europe has strong winters, very difficult to survive there. Also, it has very big prey, right, to hunt, right? While Asia does not have that much diversity in food, right? Not food is very food hunting is very difficult. I mean, is not it does not have huge prey, so it's kind of less amount of calories you get. So different kinds of environment means humans evolved differently in different areas. Like I guess example of Indonesia. Indonesia, in an island Indonesia, you had this. Once humans settled in one island in Indonesia, they were not able to move back from the island back to the mainland because of seas. So, and there was very little food there. So, since there was very little food, the people who are tall and muscular, required lots of energy, didn't manage to survive. The only people who managed to survive were dwarves, right? So humans evolved into dwarves in that particular island. So that Darwin theory of evolution. I mean, depending on your environment, you try. I mean, certain traits get more prominence, right, and certain traits deleted from any animal evolution. So just like that, he also tells it, but uh, he also tells it that human evolution was not straightforward. It's not like we were sapiens in Africa, and when we went and we are the same people, just evolved a little from from sapiens of 2.5 million or 2 million years ago to how we are now. But there were also, I mean, we had something called Neanderthals. We had Homo erectus, Neanderthals in Europe and I think Middle East, and you had Homo erectus in East Asia, and you had Denisovans. So all these, when we move from Africa towards this, there are already these kinds of humans existing, but somehow we managed to overpower them or and become the sole humans. He gives reasons why it is that. So also talks about the human brain. Now, funny thing about human brain is that you don't require such a big brain for evolution. I mean, for survival, not evolution. You don't require such a developed brain for survival. Just for example, you have different animals, right? Different types of animals. Now, obviously, you will require something more stronger, like lions develop compared to deers. Lions are much more stronger, right? Compared to deers and their prey. But the so you require something else to hunt. I mean, to survive. So nature gives you certain tools to survive through evolution, but brains were not meant for survival. And the amount of the difference of human capacity or human in human brain is much more than any of our nearest things like apes, even dolphins, right? Or killer whales. I mean, we are much our human brains are much developed than these creatures. So why is that so much difference, right? Human brains do not give you the by. I mean, uh, you don't require to think a lot just to hunt, right? At the start, you require speed, you require muscles, you require this. So other animals got those things. I mean, they got brain, but they got other things like muscles and stuff like that, right? Humans were unique in that aspect that our muscles atrophied, right? because we required energy for human brains. See, he gives an example of how much energy a brain requires. Right, human brain requires around 25% of the total energy at rest. Maybe when you are sleeping, we still require 25% of the total energy just for our brains, and human brains are just around 3 to 5% of our total weight. So we require so much energy just to think. I mean, when you're sleeping, we require 25%. I mean, when you're rest, we require 25% energy. But when we are actually thinking, we require more. Compared to that, apes just require around 8%. So we are actually diverting our energy from hunting toward thinking, right? So at the start, I mean, why would our brains get developed subsequently? But he also tells you that at the start, around 2.5 million years ago, our brains were had half the capacity as it is now, right? After 2 points, so we gradually evolved even a capacity to think. Gives a reason why did it happen. I mean, and at least certain causes, certain reasons why it might have happened. So uh, I mean, yeah, just if you're thinking about if you're just thinking and not able to hunt, right? You require speed, you require energy to hunt. I mean, you're just thinking about it. You might not be able to hunt as effectively, obviously. But then we have this thing called as but then we developed. I mean, we also had we were walking upright, but we also had hands, and we had these upright the opposable thumbs, right? And we had fingers. Opposable things, thumbs also are available in other animals, right? In some other animals like apes and stuff. Not all, very few, but still opposable thumbs in humans are much more unique because it blends well with the other fingers, right? It allows you to much more things with. So ape can't do, even if it has opposable thumb, its hand is not as capable as our hands. So our hands evolved, right, to keep our fingers, muscles within our fingers, in our wrists, and in our palms. All this allowed us to create tools, right? Even apes can not rudimentary tools. I mean, really well developed tools. So even apes can throw stones to attack their enemies. But we not only can even sticks. We not only can throw sticks. We can sharpen the sticks into spheres. Now, there's a relation between hands and brains, right? If you can develop tools, well-developed tools, and then link them, I mean, we can use our brains to actually, uh, know when to hunt, right? Or how to hunt, and when exactly to throw the spear. So that comes through experience, of course, but also. I mean, there are very new scenarios, right? Supposing the prey is hiding or is you have moved somewhere to a mountain and you are not familiar with the mountain landscape, but still you can use your brain to know that when is the best place to ambush the prey, when is the best place to hide there. 1 second. I'm sorry for that. The phone was ringing. So, when is the best place to actually ambush the prey? When is the best time to throw the sphere and stuff like that? So, basically, like, require the brains, the dialogue between our brains and our hands to actually do that thing. So we actually, so our brains developed. Now nature actually um, had to create better brains, because let's assume we are not using muscles as much as we used to before. Now we are using tools. We are using brain. We're using our brain power. Now, to survive among the other to survive and thrive among other humans, you require you require better brain power. You require more sophisticated I mean, you require more control over your hands. So nature, I mean, those who didn't have as much brain power as the rest of the tribe, or were not able to control were not able to use their hands as much as effectively as the other members of the tribe, had fewer children. Those who could, I mean, became those who had better brain power, better control over the hands, became leaders, and obviously those who are leaders had more children. So that evolved into slowly more and more brain power, right? So it did increase. So hands actually, I mean, contributed to our bigger brains. Also, like, we managed to control fire, right? Now what happens when you control fire? We can, I mean, what is the fire used for? Keeping warm, right, in wintry environment. Also, seeing that our prey does not ambush us at night. Okay. And then you have main thing was about cooking food. Now about cooking food is that, since if you could cook food, right, things which you could not eat normally raw, and if you can cook them, and now we can eat them, like barley, wheat, rice, and stuff like that. We don't need to hunt as regularly as we used to. So now we have saving energy, right? So that energy can go back to into creating better brains, right? Also, one aspect of that, if you eat raw food, you need a larger intestine to digest. Bigger intestine creates more energy, right? Requires more energy to digest. I mean, it has to go through the full area of the intestine. Raw food is hard to digest and stuff like that. And requires more acid, more energy. But since we are one now cooking food, the energy required was reduced. I mean, so now we could more energy could nature could give more energy to create better brains. So again, our brain capacity started increasing because we could cook food now. But that creates a again, see, if you think about it a moment, like, um, other animals can control nature a minuscule. I mean, we are much powerful. We can control nature much more effectively and to a huge extent than any other animals can. So why did nature allow us to be so powerful, right? I mean, what is again nature's rules, right? To survive and to multiply, right? Just these two rules, right? There is no. I mean, nature does not support the one which can dominate itself, right? It does not. It does not create weapons for its own destruction, right? So having a better brain, having more agile hands, goes against the nature's first two rules, right? uh, how about, I mean, it's in thriving and in multiplying and in surviving, right? So why did nature allow us to be so powerful? um, I mean, so for example, you can think about in a physics experiment, the double slit experiment, right? uh, See, what does the double slit experiment do actually? It's physics and astronomy. It tells you that for light, which if you capture, I mean, light can act as a dual nature. It can be wave as well as a particle. So if it's a wave as well as a it can be act like wave as well as a particle. Now, how do we measure that? Let's assume you have a photon, you flash a light through a paper or whatever a barrier which has a single slit, and you have a screen at the end to capture the light rays. Uh, what it shows you that light comes and falls as a particle, right? There is no, it does not act like a wave. But what happens? I mean, it has points. I mean, on the screen you will find these points. What happens when you create two slits, so double slit on that sheet of paper and then pass a light through it? You would expect that light, if a light is a particle, it can only go in through one slit, the left or the right slit. So you'll have two. You finally on the screen you'll find two different strips, right? As you would expect, in a single slit, you will have a single strip of photons on the screen. But if you are double slit, you will have the two sets of two lines, right? One photon going in through one slit, one photon going through another slit, right? But what you see is that you see, as if you see an interference pattern. You see a wave. Uh, uh, when you drop a pebble through on the lake, you see a wave spreading out. Similar, if light was of a particle, it would have formed two lines, but instead it forms, it acts as if as if the photon has gone through both slits and then created troughs and depressions to create a wave pattern on the screen. So now light is acting as a wave, right? It was a single slit was acting as a particle, double slit is acting as a wave. So what does it? I mean, but that is not the issue here. What I'm talking about relates is if you actually try and measure these photons which are passing through, which have gone through the slit, right? So it goes through. It's acting as if it's passing through both slits as a wave, right? So what you try is you try to measure, you try to put a detector and try to see exactly if that is the case, right? You put detect on the left slit and you put a detector on the right slit and see if it's acting as a wave. I mean, is it passing through both at the same time, right? But when you put a detector, it acts as a particle. It does not go through both slits. That's the surprising part. It does not go through both slits. Acts like a particle, and it goes through only one slit. And you find again, you don't find a interference, a wave interference pattern, but you find again two vertical lines. That is each photon is going through just one slit. So basically, what it tries in is kind of it's kind of a conclusion is that when you're trying to detect if the light is a particle or a wave, or if you're trying to detect if light has gone through both slits at the same time, it acts like a particle and goes through only one slit. So it's not telling you, this universe is not telling you its secrets or what it's doing when you're not looking. So basically, what it says is that if universe is actually trying to hide all its such a minuscule secret of its own, and yet it allows us to not only create rockets to create a nuclear bomb, to create rockets to bomb the moon, bomb Mars, stuff like that. No, destroy universe itself. I mean, in 100 to 500 years, we could even destroy the our solar system if needed, right? We can destroy Earth now, but in 500 times you could even destroy 500 years. You could even destroy our solar. So why has the universe given us so much power, right? To if it's hiding its small secrets, and yet it gives us so much power to destroy universe itself, destroy uh, parts of the, I mean, a small part, very small part, but still parts of the universe, right? One more thing it has we have developed is, I mean, we always walking on two legs. We had upright position, so it gave us some advantages, but it also meant that we need to have smaller hips, because larger hips means we can't walk or run as fast. But smaller hips means that humans, the babies which were born, couldn't pass through the birth canal. So babies had to be born kind of premature, in the sense like other animals within 6 months, they within a few months they're able to walk, but human babies can't walk or run for some time, much more than animals. So human baby, those who could, those women which could give babies, I mean, babies were born premature because of evolution. I mean, at least babies were, I mean, we require lots of training before we actually be able to contribute to society. So same thing with, I mean, since women couldn't hunt, we required social skills. I mean, to better take care of our babies, because babies were very fragile. I mean, they were kind of born premature. So one more thing is about checks and balances, in the sense that nature, I mean, every evolution is slow process. I mean, if you have if you create a prey like a deer, okay, you give it fast legs so that it can escape uh, the escape the lion, because lions will not get as fast legs as a deer. If lions were given faster legs, deer were given even faster legs, right, to escape. Otherwise, nature, no one, they only lions would, no one would survive. Even lions would die because they would not find enough prey. So nature, actually, evolution is kind of a slow process. As you're giving one thing to the hunter, you're giving one thing to the prey. But when it came to humans, humans became humans developed very fast. I mean, it developed much more faster. Than nature could not provide any defense mechanism to other animals. So there were no checks and balances. So that's because of our brain again. Uh, I think I talked about the fire, right? What else? So one more thing is that when humans were there, they were Neanderthals, they were Denisovans, uh, Denisovans, they were Homo erectus, and stuff like that. So all these people were there. Why did humans or Homo sapiens dominate everyone? There are two theories. One of them is that there was interbreeding between Homo sapiens, Neanderthals, Denisovans, Homo erectus, and we are a mixture of all these different branches of our evolution. So, but then when we were actually DNA is analyzed, we found that only 1 to 4% of our DNA is of Neanderthals, just very small percentage. So there was interbreeding, was not as much as that we could completely. I mean, we could say we are actually a mix of Neanderthals and Homo sapiens. But what happens is that there's another theory called replacement theory. That means we somehow became much more capable of killing in battles. Maybe there were some battles between Neanderthals and humans. We were and Homo sapiens. We were much more capable than Neanderthals. But Neanderthals had bigger brains. They had bigger brains. They had more muscular. So how did we? I mean, bigger brains do not equate to better intelligence. But still, they were maybe as capable as us. How did we manage to dominate the Neanderthals, right? So he gives the starting of the reason that maybe it's about that we learned language in the sense that uh, Neanderthals were giving sign signals in a battle, assuming it's in a battle. They're giving sign signals while we were actually talking to our colleague or to our friends or to comrades in battle. Right, we were actually telling them how that person is attacking me here. Can you come and help and stuff like that? We are actually talking in a language, while Neanderthals were just still giving sign language. And so, in places, many areas where the supposing it's a thick wood, language will carry much forward than sign language. So maybe that was an advantage, and we became more social because of language, right? So it became social because we had bigger groups, right? So that could have been the reason. So yeah, that's enough for today. Thanks. Bye.